Current is measured in amperes, or simply amps. In general, in order to have a current, like in a river, something must flow from one point to the next. Without any movement, current cannot exist. In a circuit, we have electrons flowing. Electrons always flow from points of low to high voltage. In general, electrons travel in random directions, but the group of electrons always flows in a single direction. In our examples, electrons will travel from node D to C to B and to A. Current is a measure of the speed of flow. In a river, the faster the water particles travel downstream, the higher the current. Similarly, in a circuit, the faster the electrons flow through the wire, the higher the electric current. We said that electrons move from points of low to high voltage. By convention, the direction of positive currents is opposite to the direction of electron flow. So the positive direction of current is always from nodes of high voltage to nodes of lower voltage, although current can be specified in any direction. Suppose the current going from B to C is 1 amp. Then it's also true that the current going from C to B is negative 1 amp. Just like the voltage can be positive or negative based on the reference node, current can change polarity based on the chosen direction for analysis. Zooming into our circuit, if electrons flow from right to left, the direction of positive current will be from left to right. Note that the direction of negative current is the same as that of electrons. Electrons need a wire to flow, but a wire alone is insufficient. In order to have a current flowing, a closed loop must exist. In our example, there is a closed loop that goes around the 2 batteries and the 2 light bulbs. But if any node in the circuit is not connected, the electrons cannot flow and no current is present. When a node is not connected to anything, it is called an open circuit. If we do not have a closed loop, no current can flow and the light bulbs turn off. This is the use of switches in a circuit. Every time the switch is flipped off, the circuit opens and the light turns off. When the switch is flipped back on, the circuit node connects, electrons start flowing, and the light turns on. When the switch closes the circuit, it connects 2 wires together, creating the necessary loop for current to flow. Nodes in an open circuit can have different energy levels, therefore a voltage. But no current can flow in an open circuit. Electrons just don't have a path. In our example, a voltage VED may be greater than 0 volts, but no current flows from E to D. In fact, no current flows anywhere on this circuit because we do not have a closed loop.